My name is Madhuri Gupta, Assistant Professor, Department of Computer Science and Engineering, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Today's topic is AO star algorithm. Let's have a quick recap of the last class on A star algorithm. The A star search algorithm is a widely used and popular search algorithm commonly employed in pathfinding and graph traversal problems. It is designed to find the shortest path between a starting node and a goal node in a graph or a grid, while considering both the actual cost to reach a node and an estimate of the remaining cost to reach the goal. A star combines the strength of two other algorithms, that is Dijkstra algorithm and greedy best first search. The main idea behind A star is to prioritize exploring nodes that seem most likely to lead to the goal. It achieves this by using two key components for each node. First, cost function g. This represents the actual cost of getting from the starting node to the current node. Second, heuristic function h. This estimates the cost of getting from the current node to the goal. The heuristic function is admissible if it never overestimates the true cost. A star uses a priority queue, often implemented as a mean heap, to expand nodes in the order of their estimated total cost, which is given by f of n is equal to g of n plus h of n. At each step, the algorithm selects the node with the lowest f value and explore its neighbors. The algorithm continues until the goal node is reached or the open list, that means priority queue, is empty, indicating that the priority is no path to the goal. If the heuristic is consistent, that means also known as monotonic, A star is guaranteed to find the optimal path. A star combines the completeness and optimality of Dijkstra's algorithm with the efficiency of greedy best first search by considering both the actual cost and the estimated remaining cost. This makes A star a powerful algorithm for solving various pathfinding problems such as finding routes on maps, navigating robots and planning trajectories. While A star is highly effective and efficient, it is important to note that the choice of heuristic can significantly impact its performance. A well-designed heuristic can guide the algorithm towards the goal more accurately and help reduce the number of nodes that need to be expanded. In summary, the A star search algorithm is versatile and widely used technique for finding optimal paths in graph and grids. Its fundamental concept in computer science and is applied in numerous real-world scenarios where efficient pathfinding is essential. Best first search is what the AO star algorithm does. So, we have now our today's topic, the AO star search. The AO star search method divides any given difficult problem into a smaller group of problems that are then resolved using the AND OR graph concept. AND OR graphs are specialized graphs that are used in problems that can be divided into smaller problems, where the AND side of the graph represents a set of tasks that must be completed to achieve the main goal, while the OR side of the graph represents different methods for accomplishing the same main goal. In the above figure, the buying of a car may be broken down into smaller problems or tasks that can be accomplished to achieve the main goal in the above figure. While is an example of a simple AND OR graph. The other task is to either steal a car that will help us accomplish the main goal, or use your own money to purchase a car that will accomplish the main goal. The AND symbol is used to indicate the end part of the graph, which refers to the need that all sub-problems containing the AND to be resolved before the preceding node or issue may be finished. The start node and the target state are already known in the knowledge based search strategy known as AO star algorithm, and the best path is identified by heuristics. The informed search techniques considerably reduces the algorithm's time complexity. The AO star algorithm is far more efficient in searching AND OR trees than the A star algorithm. So, let us have the algorithm for AO star search. Step 1. Let G be a graph with only starting node init. Second, repeat the following until init is labeled sol or H init is greater than fertility. Step A. Select an unexpanded node from the most promising path from init. Call it node. Step B. Generate successors of node if there are none. Set H node is equal to fertility, that means node is unsolved. Otherwise, for each successor that is not an assenter of node, do the following. Step 1. Add successor to G. Step 2. If successor is a terminal node, label it sol and set H successor is equal to 0. Step 3. If successor is not a terminal node, complete its H. Step C. Propagate the newly discovered information up the graph by doing the following. Let S be the set of solved nodes or nodes whose H value have been changed and need to have values propagated back to their parents. Initialize S to node until S is empty. Repeat the following. Step 1. Remove a node from S and call it current. Step 2. Compute the cost of each of the arcs embedding from current. Assign minimum cost of its successors as its H. Step 3. Mark the best path out of current by making the arc that had the minimum cost in step 2. Step 4. Mark current as solved if all of the nodes connected to it through new label have been labeled solved. Fifth, if current has been labeled solved or its cost was just changed, propagate its new cost back up through the graph. So, add all of the assenters of current to S. So, now have a working of AO star algorithm. The evolution function in AO star looks like this. F of n is equal to G of n plus H of n. F of n is equal to actual cost plus estimated cost. Here f of n is equal to the actual cost of traversal. G of n is equal to the cost from the initial node to the current node. H of n is equal to estimated cost from the current node to the goal state. So, now have some differences between the A star algorithm and AO star algorithm. A star algorithms and AO star algorithm both works on the best first search. They are both informed search and works on given heuristic values. A star always gives the optimal solution, but AO star doesn't guarantee to give the optimal solution. Once AO star got a solution, doesn't explore all possible paths, but A star explores all paths. When compared to the A star algorithm, the AO star algorithm uses less memory. Opposite to the A star algorithm, the AO star algorithm cannot go into an endless loop. Now we can understand this problem by using some examples. So we have this example where you can see in this diagram we have 3 levels of tree, where it is a start from the A, then it will cost the value of 6, then B, and the A has the successor B, C, D, and the B has successor E and F, C has successor G, H, I, and the D has successor J. So the AND OR graph will start from the terminals. So here you can see that E and F has the cost value 7 and 9, and we can calculate the G as 1. So in this diagram we can see the value of H as given in the figure. Next, in the step 2 we will explore the next step. Here in the above example, below the node which is given is the heuristic value, that is h of n. Age length is considered as 1. So here we have step 1. So start from A and then we will go with the terminal. So here we have the start node A. So our step 1 is to start from A. So we have in the terminals value 7, value E and F is 7 and 9. Then we have G, H, I has 3, 0, 0, and in D we have J is equal to 0. So because 7 and F is equal to 7 and F is in OR node, so we can calculate or take the minimum value. So in this diagram we can take the minimum value. So in the next step, step 2, we will explore the next value. With the help of f of n is equal to g of n plus h of n evolution function, start from node A. F of A to B is equal to g of B plus h of B, that means 1 plus 5. Here g of n is equal to 1 is taken by default for path cost, so total value is equal to 6. So now f of A to C plus D. So we have g of C plus h of C plus g of D plus h of D is equal to 1 plus 2 plus 1 plus 4. Here we have added C and D because they are in AND. So we have total value is equal to 8. So by calculation A to B, path is chosen which is minimum path, that is from F A to B. So we have the path from A to B. So now this in step 2. Step 2, you can see in the diagram we have changed the value. We have changed the value from 6 to 9 and from 9 to 8. So according to the answer of step 1, explore node B. Here the value of E and F are calculated as follows. F B to E is equal to G of E plus H of E. F of B to E is equal to 1 plus 7 is equal to 8. Now F of B to F is equal to G of F plus H of F. So we have F of B to F is equal to 1 plus 9. So total is 10. So by above calculation, B to E path is chosen where is minimum path, that is from F B to E, because B's heuristic value is different from its actual value. the heuristic is updated and the minimum cost path is selected. The minimum value in our situation is 8. Therefore, the heuristic for A must be updated due to the change in B's heuristic. So, we need to calculate it again. So, from f A to B is equal to G of B plus updated HB. So, we have 1 plus 8 is equal to 9. We have updated all the value in above tree. Step 3, you can see in the figure the changes. By comparing f of A to B and f of A to C plus D, f of A to C plus D is shown to be smaller, that is 8 is less than 9. Now, explore f of A to C plus D. So, the current node is C. So, f of C to G is equal to G of G plus H of G, means f of C to G is equal to 1 plus 3, that means 4. F of C to H plus I is equal to G of H plus H of H plus G of I plus H of I. So, from f C to H plus I is equal to 1 plus 0 plus 1 plus 0. Here we have added H and I because they are in AND. So, we have total value is equal to 2. F of C H plus I is selected as the path with the lowest cost and the heuristic is also left unchanged because it matches the actual cost. Path H and I are solved because the heuristic for those paths is 0. But path A to D needs to be calculated because it has an AND. So, f of D to J is equal to G of J plus H of J. So, f D to J is equal to 1 plus 0 is equal to 1. The heuristic of node D needs to be updated to 1. F of A to C plus D is equal to G of C plus H of C plus G of D plus H of D is equal to 1 plus 2 plus 1 plus 1. So, we have total value is equal to 5. As we can see that path f A to C plus D is get solved and this tree has become a solved tree now. In simple words, the main flow of this algorithm is that we have to find firstly label first heuristic value and then label 2, and after that update the values with going upward, means toward the root node in the above tree diagram. We have updated all the values. So, we have another example where you can see that we have the A value. Here we have A is the only node. It is at the end of the current best path. It is expanded yielding nodes B, C, D. The arc to D is labeled as the most promising one emerging from A, since it cost compared to B and C, which cost 9. Step 2, in this diagram you can see the value of A and the successor B, C, D, which has the cost 3, 4 and 5, and we have G as 1. So, we have value 3 plus 4 is equal to 7 plus 1 plus 1. So, we have AND node total value is equal to 9, and we have the OR node is 5. So, we have to compare this 9 value with 5. So, we have minimum path value is equal to 5. So, we will move towards D. Node B is chosen for expansion. This process produces one new arc and the AND arc to E and F with a combined cost estimate of 10. So, we update the F value of D to 10 going back one more level, we see that this makes the end arc B to C better than the arc to D. So, it is labeled as the current best path. So, now in the step 3, you can see in the diagram we have explored the successor of D, which has the value E and F, which has the cost 4 and 4 because it is the AND node. So, we have to calculate 4 plus 4 is equal to 8 plus G of G cost is equal to 1. So, 1 plus 1. So, we have 4 plus 4 8 plus 1 plus 1, that means 10. So, we have total value 10. We traverse the arc from A and discover the unexpanded nodes B and C. If we going to find a solution along this path, we will have to expand both B and C eventually. So, let us choose the explore B first. This generates two new arcs, the ones to G and to H. Propagating their F values backward, we update F of B to 6, since that is the best we think we can do, which is can achieve by going through G. This require updating the cost of the AND arc, that is B to C, to 12, that means 6 plus 4 plus 2. After doing that, the arc to D is again the better path from A. So, we record that as the current best path, and either node E or node F will chosen for expansion at step 4. Now, in the step 4, you can see in the diagram we have explored all the successors of B and D. So, we have G is equal to 5, H is equal to 7 and E is equal to 5 and F is equal to 4. So, we have to update our AND value 5 plus 5 and 7. So, we have to explore this path. So, 5 plus 1 is equal to 6. We have to choose the minimum ones because this is the way you can solve it. So, I hope that example has been understood by you, and now we have some another example. We have the graph. So, in this example we have the graph which has node A, B, C, D, E and F. So, we have the heuristic value of A is equal to 8, B is equal to 2, C is equal to 2, E is equal to 1, F is equal to 0 and D is equal to 8, and the remaining cost is the G cost. So, how can we solve this problem? We can go with step by step. So, in step 1 we have A is equal to 8, means the heuristic value of A is 8. Step 2, now we have to calculate the AND and OR value. So, here we have B is equal to 1, C is equal to 2 and D is equal to 8. So, we have to calculate because it is a AND node. So, we have to calculate 2 plus 1 is equal to 3 plus 4 plus 5 is equal to 12, and here the in OR side we have the value 8 plus 5 is equal to 13. So, by comparing 12 and 13 we get the 12 value, that is minimum. So, we move towards A to B, and in step 3 we have to again calculate the value from B to C because C is the current neighbor of B. So, we have to calculate it again with calculate the C value. So, we have 4 plus 2 is equal to 6 plus 2 is equal to 8 plus 4 is equal to 12 and plus 3 is equal to 15. So, we have to again compare the value. So, we have 13 and 15. So, we have to move towards the minimum value. So, we will move again update the value. So, we will move towards D, and in step 3 now we have to expand the successors of D where the value is E and G, where E has the heuristic value 1 and G is the heuristic value 0. So, by calculating the value 1 plus 1 we got 2 and here 0 plus 4 is equal to 4. So, we have to move towards D to E. Now, in the next step we have to explore from E to G, which has the cost value 3. So, in total we got the value 9, which is again less than 15. So, we have to move towards A to D and D to E and E to G. So, we have solved this problem by using AND OR algorithms. Now, we come to the point where we can explore the real life application of AO star algorithms. So, first is vehicle routing problem. The vehicle routing problem is determining the shortest route for a fleet or vehicles to visit a set of customers and return to the depot, while minimizing the total distance travelled and the total time taken. The AO star algorithm can be used to find the optimal routes and satisfy both objectives. Second is portfolio optimization. Portfolio optimization is choosing a set of investments that maximize returns while the minimizing risk. The AO star algorithm can be used to find the optimal portfolio that satisfies both objectives, such as maximizing the expected return and minimizing the standard deviation. In both examples, the AO star algorithm can be used to find the optimal solution that balance multiple conflicting objectives, such as minimizing distance and time in the vehicle routing problem or maximizing return and minimizing risk in the portfolio optimization problem. The algorithm starts with an initial solution and iteratively improves it by exploring alternative solution and keeping the best solution that satisfies both objectives. So, in our upcoming lecture, we have the topic constraint satisfaction problem, CSP. A constraint satisfaction problem, CSP, is a computational problem in the field of artificial intelligence that involves finding a solution that satisfies a set of constraints or conditions. It is formal framework used to model and solve problems where the goal is to find values for a set of variables that meets specified constraints. Here is a brief overview of CSP. First, components, variables. The variables, this represent the unknowns or entities whose values need to be determined. Next, domains. Each variable has an associated domain which defines the possible value that the variable can take. Next is constraints. Constraints are restrictions or relationships that specify which combinations of variable values are valid or allowable. Second, objective. The objective of solving a CSP is to find an assignment of values to variables that satisfies all the given constraints. The goal is to find a solution that respects all the conditions imposed by the constraints. So, thank you for watching and we will see you in the next exciting lectures. Thank you so much.